Happy learning! Today we're going to talk about derivative rules. And by the end of today's lesson, you're going to say, derivatives rule. Okay, so let's start with the product rule, right? We've already talked about how to take the derivative of x raised to a power. Let's now talk about a product. So this is the product rule. It says if f of x is the product of two functions. So I'm going to say if f of x is g of x times h of x, right? If we have the product of two functions, then f prime of x. So how do you take the derivative of a product? It's you keep the first function the same and then multiply by the derivative of the second function plus the derivative of the first times the second. First times the derivative of the second plus the derivative of the first times the second. All right, and that's how you take the derivative of any product. So let's take a look at an example. If f of x is equal to 2x to the third plus 3x plus 1 times x squared plus 4, we want to find f prime of x. All right, and so this function is a product, right? It's the product of these two functions. And so to take the derivative of a product, we're going to use the product rule. So we have to identify what's g, what's h, what's g prime, what's h prime. G is the first term. So we don't really need parentheses here. And h is the second term. And what do we need for our rule? We need g prime and we need h prime. What is the derivative of 2x to the third plus 3x plus 1? We bring the power in front. Subtract 1 from the exponent. And we do that for each of the terms. So the derivative of 3x is just 3. And the derivative of 1 is 0, so we don't have to include that. Oops. H is x squared plus 4, so sorry about that. And what's the derivative of x squared plus 4? It's 2x. All right, so we've done the hard part. And now we know that the derivative is equal to g times h prime plus g prime times h. All right, and you can just leave it like this. So that's how you take the derivative of a product. Let's now take a look at the quotient. All right, so the quotient rule is going to tell us how to take the derivative of, well, you guessed it, a quotient. It says if f of x is equal to g of x over h of x, then to take the derivative of a quotient, it's h of x times g prime of x minus g of x, h prime of x, all over h of x squared. So it's low d high minus high d low over low squared. Bottom times the derivative of the top minus top times the derivative of the bottom over the bottom squared. All right, so let's take a look at an example. So if f of x equals x squared minus 4x over x plus 5, we want to find f prime of x. All right, so here we have a quotient, so we're going to use the quotient rule. So a big challenge in like these finding derivative problems is identifying which rules to use, because typically you're not told which rules you have to use. You have to identify what type of function we have, and then from there you decide which rules you're going to use. And sometimes multiple rules apply, so you just got to pick which one you think is appropriate. All right, so here we have a quotient, so very clearly we should use the quotient rule. And so what do we need? We need g and h, and then their derivatives. So let me write this correctly this time. G of x is our numerator. And h of x is our denominator. All right, and if we look at our rule, we need the derivatives of both the numerator and the denominator. The derivative of x squared minus 4 is, the derivative of x squared minus 4x is 2x minus 4. The derivative of x plus 5 is 1. Right, you could imagine x is like really just x to the first, so you'd bring the 1 in front and it'd be 1 times x to the 0. All right, and now we're good to go. We just basically plug it into the formula. So f prime of x is equal to the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, and this is a perfectly fine way to leave it. If you want, we could clean this up a bit by distributing and then combining like terms, and it simplifies to x squared plus 10x minus 20 over x plus 5 squared. But really, there's no need to simplify. So I mean, this is typically how I would leave my answer. OK, and so one last rule I want to talk about today is the chain rule. All right, so the chain rule will allow us to take the derivative of basically any other function, with some exceptions. But the chain rule is a very important rule. And the chain rule tells us how to take the derivative of the composition of functions. All right, so the chain rule says if f of x equals g of h of x, All right, so if our function is the composition of two functions, then the way we take the derivative of the composition of two functions is we take the derivative of the outside function composed with the inside function times the derivative of the inside function. All right, so it's the derivative of the outside function times the derivative of the inside function. All right, so let's take a look at an example. So if our function is f of x equals the square root of x squared plus 1, let's find f prime of x. All right, and so what we want to do is we want to express our function as the composition of two functions. All right, so this function is not a product. It's not a quotient. It's not just x raised to a power. So none of our old rules apply. Right? We have to use, or we got to try to use the chain rule. Okay, and so typically, right, this is the inside function. So x squared plus 1 is going to be our inside function. And then what's happening to x squared plus 1? We're taking the square root of it. So that's our outside function. So our outside function is x to the 1/2. Our inside function is x squared plus 1. All right, so what bits of information do we need? We need the derivative of our outside function composed with our inside function. So let's just find the derivative of our outside function first. What's the derivative of x to the 1/2? Well, we bring the power in front and subtract 1 from the power. Right, 1/2 minus 1 is negative 1/2. Okay, we need g prime composed with h. All right, so I guess I'll use this space here. G prime of h of x. How do we do that? Wherever we see an x in our g prime function, we're going to replace it with the entire h of x function. We see an x right there. We're going to replace it with this. All right, this is g prime of h of x. What else do we need? We need h prime of x. H prime of x is 2x. All right, so we're good to go. F prime of x is this. Times 2x. Okay, 2 times 1/2, that's 1. And x squared plus 1 to the negative 1/2, that's the square root of x squared plus 1, but in the denominator. So this simplifies to x over the square root of x squared plus 1. All right, and so let's now write a special case of the chain rule. Which is when we have a function raised to a power. Okay, so the chain rule applies for the composition of any functions. It could be like e to the 5x. We would use the chain rule. But I'm going to look at a very specific application of the chain rule. So this is the power and chain rule. So if we combine these two great forces into one superpowered theorem, this is what we're getting. Okay, and so what does it say? It says if f of x equals some function, g of x, raised to a power. All right, so if f of x is some function raised to an exponent, then f prime of x. Well, we want to use the power rule and the chain rule. What does the power rule say? It says bring the power in front, subtract 1 from the power. What does the chain rule say? It says, for the love of God, you better remember to multiply by the derivative of the inside function. So let's multiply by the derivative of the inside function. And so this is how you take the derivative of any function raised to a power. All right, so let's take a look at a few examples. So find the derivative of the following. First, x squared minus 4x raised to the 6th. And second, f of x equals 4 over 3x squared plus 1. Okay, I'm going to start with this one, and then we'll do this one a couple of different ways. Right? Because we're going to see that there's multiple routes that we could take to get to the right answer. So it's really just whatever you feel comfortable with. All right, so here we have x squared minus 4x raised to the 6th. Let's call this, I don't know, let's call this y. All right, so for a, y prime equals, we bring the power in front, do not touch the inside. Subtract 1 from the exponent. And now we multiply by the derivative of the inside. All right, so it's, I know a number of you right now are tuned out, but tune back in. Bring the power in front, subtract 1 from the power. Don't touch the inside. Then multiply by the derivative of the inside. Okay, power in front, inside stays the same. Exponent goes down by 1 times the derivative of the inside. That is the derivative of x squared minus 4x raised to the 6th. All right, now let's do b. We're going to do b in two different ways. First, we're going to do it with the quotient rule, right? We have a quotient. So we could use the quotient rule. And then the second way we're going to do it is with the power and chain rule. We should get the same answer both times. All right, so b with the quotient rule. F prime of x. So what is the derivative of a quotient? It's the bottom function, 3x squared plus 1, times the derivative of the top. The derivative of 4 is 0. Minus the top, 4, times the derivative of the bottom. What is the derivative of 3x squared plus 1? We bring the power in front. 6x. All over the bottom squared. So that's 3x squared plus 1 squared. All right, this simplifies to negative 24x over 3x squared plus 1 squared. This is the right answer. All right, so you could be done if you wanted to. But I'm going to do it both ways. So quotient rule is our first attempt. If you notice, this function we could actually rewrite as 4 times 3x squared plus 1 raised to the negative 1 power. right? These are equivalent. A fraction is the same thing as a negative exponent. Being in the denominator is the same thing as appearing with a negative exponent in the numerator. All right, and so now I'm going to take the derivative of that using the power and chain rule. So what do? We bring the power in front. Do not touch the inside. Subtract 1 from the exponent. Negative 1 minus 1 is not 0, it's negative 2. Multiply by the derivative of the inside. The derivative of the inside is 6x. Okay, and now we could simplify this. Negative 4 times 6x is negative 24x. And then instead of having the negative exponent, I'm going to put that bad boy in the denominator. And you could see if we use the quotient rule, we get one answer. If we use the power and chain rule, we get the same answer. So you get a pick. There's no right or wrong way to do these. Well, there are obviously wrong ways to do it, but there are many right ways to do this. So when you see a problem that you have to take the derivative of, you have to identify what rules can I use and which rules do I want to use. So if you really like the chain rule, then use the chain rule. If you really like the quotient rule, use the quotient rule. Okay? That's all I have for today. You now know how to take the derivative of almost every function. So be proud of yourself. I'm proud of you. Okay, bye-bye.